Hi there, this is Juhi and Abhishek studying the inflorescence in the wildflower Lantana Camara. Why study L. Camara though? It is an extremely adaptable species that can live in a wide range of environments. Once introduced into a habitat, it quickly spreads. It has become an invasive species in many continents and has the potential to outcompete native species, reducing biodiversity. L. Camara has small tubular-shaped flowers which each have 4 petals and are arranged in clusters in terminal area stems. One can see a variability in the number of these flowers in individual inflorescences at first glance, and that certainly seems something interesting to study. The wonder does not cease when it comes to Camara. After pollination occurs, the color of the flowers changes from yellow to pinkish in the type of L. Camara under observation. This is believed to be a signal to the pollinators that the pre-changed color contains a reward as well as being sexually viable, thus increasing the pollination efficacy. Pollinator behavior inside and across plants has a significant impact on the reproductive outcomes of animal pollinated plants. In plants that display inflorescences, all open flowers can actually act together to attract pollinators, enhancing pollen export, import, and potential mate diversity. So the pattern and size of these inflorescences might help draw crucial conclusions about the overall reproductive allocation of the plant. Let's pan out to Abhishek right from the field.
Hi, I'm Abhishek and I'm with L. Camara plant, and this is a small size herb that is located at the back of our Nivedita hostel, and here I'm going to show you how I'm taking observation for this. So here I choose randomly any of the flowers. For example, this is a L. Camara flower clusters, and it has 2 types of flowers. So one are a bit different in color. In center we have flowers which have white spots in the center, and then the other flowers which are mostly pink at the periphery. So what we're gonna do is we're gonna count the number of white flowers, white with yellow patches. Those I'll be considering them in the center, and the ones which are in complete pink and they are in periphery, so that I'm gonna count in the other column. So here, for example, I have 1, 2, 3, 4, 5 flowers which are whitish in color, white to yellowish. So I'm gonna write 5, and then the other one which are complete pink, 1, 2, 3, 4, 5, 6, 7. So this I have recorded in my field notebook, as here you can see. So this is my way of taking observations. So when I'm collecting it from the plant, what I do is I pick a random flower from it, and then after taking the observation, what I do is I usually either pluck it out or either I twist its stem so that I don't recount it. So that's my methodology for taking. Bye bye. See ya.
With all the data collected, let's try to make sense of it. We have plotted the histogram for the pink and white-yellow flowers separately. We have taken 135 individual inflorescences into account from 21 plants. This plot is simply giving information about each individual inflorescence, how many pink and white-yellow flowers that particular inflorescence might have. We don't see any significant clustering of points, but one can conclude that the inflorescence is most likely to have a number of white flowers from between 0 to 10, both included, while that of pink flowers from 5 to 15. This sample size is very small, hence we don't expect really to see the most mind-boggling plots, but the sample size is decent enough to perform small sample tests like chi-square test, and one might even calculate the 95% confidence interval and look for outliers. The null hypothesis that we are interested in testing is that the number of white-yellow flowers in an inflorescence and the pollination depend on one another and show converges towards the mean value, while our alternative hypothesis is that these parameters are fairly independent. We know the standard chi-square test and followed the protocol accordingly. Here the degree of freedom of the system is n-1, that is 134, the critical value for which at the level of significance of 0.05 is 162.016 using the chi-square table that we have. Now finding the this is the critical value. Now we need the chi-square value, which we calculate using MS Excel. This is a quick and dirty demonstration of how we did that. We know the formula is expected minus observed whole squared by expected whole summed over the entire sample space. So our sample space of 135 like elements. So here we write the cell number A2 minus B2 whole squared, and we by B2, and we can just drag it down, so which gives us the expected minus observed whole squared by expected for each individual of the 135 entries, 135 data points. So this is how we check that, for A3 that is how it holds, and we continue for all the data points. And then we just sum it over using the inbuilt summation functionality, and we get the chi-square value, that is 341.99, which is way more than our critical value, hence we reject the null hypothesis. We most certainly had a lot of fun into bringing this little project into force, so hope you enjoy these montages of us discussing and bringing this study together. We explore the limitations, possible criticisms of the study, and further directions briefly in our report. We hope you enjoyed watching this video because we sure enjoyed making it. Bye!